Okay, this video is going to take you through how to do a regression curve in Desmos, and we're going to be working with Unit 1, Lesson 3, the example towards the end of the lesson. So you might have hopped over here from watching that video, or maybe you wanted to see like a redo of a demonstration we did in class. I don't know. But anyway, we're recording a video that demonstrates how to do that regression curve in Desmos. So up here, you'll notice this little plus sign, if you can see where my mouse is, and it says add item. And when you're doing a regression, you're doing your regression from a table. And so we're going to choose table from the dropdown. And you'll notice it says X sub 1 and Y sub 1. So that's Desmos automatically numbering it. Now, this next part is really straightforward. You're basically going to copy the table from wherever you have it into Desmos. And you would have to do this if you were using a graphing calculator or other graphing utility. So I'll do this as quickly as possible, but I wanted to make sure that I was demonstrating the entire process. If you're wondering where I got these numbers from, I did get them from lesson 3. And so you can go back into lesson 3, the video, or your notes to find these numbers. So hopefully I'm not making any mistakes. We'll find out if my numbers don't come out right, because we know what the numbers are supposed to be. What do we have? 34, 151, 47, 158, and 45 at 182. Okay, and I believe this example is the length of someone's femur compared to their overall height. Okay, now what you'll notice is that we can't see any of these points. So this little icon up here, our graphic, tells me that Desmos is plotting the points. And the reason you can't see any of the points is because our graph is not going out far enough. So we know that like on the y-axis, we need to be way up over 100. Our x-axis, I think our smallest number is 30, and we're not even close to that. So there is underneath here, here we go. This little thing right here where it says zoom fit. So you can kind of tweak the window over on Desmos like this. You can zoom in and you can zoom out, and like eventually, you know, we'd be able to find them. That obviously didn't work. But the zoom fit is just telling Desmos, hey, you know where these points are. Give me a window that will fit those points. So I'm going to go ahead and click that. And absolutely nothing happened. Hang on. There we go. Oh, wait, that does not look right. Is there a number? 47,158. That should be 47,185. Okay, so a couple of things. We're going to turn this into a little bit of a teaching moment. First of all, the mistake that I made there was I transposed the digits. So that's actually a really, really common mistake. Obviously, like anybody can do it. So the number that was supposed to be right there is 185, and I said 158. So if you tend to make those kinds of mistakes, okay, the name for that kind of mistake is called your transposition error, your transposed two digits. The other thing just to point out is that that point, when we looked at the graph, clearly looked out of place with the rest of them. Now, it's possible that you can have a point that is like what we call an outlier. It's away from the rest of the data. That does happen, but it is that cause to like trigger, oh, let me go back and make sure that I did that right. So just, you know, I made a little bit of a mistake there, and you know, we'll just use that as a learning opportunity so that you can help diagnose and articulate like when you make a mistake too. Okay, so what we can tell by looking at this is that this data is clearly linear. All right, so the longer someone's femur is, the taller they are. And that's a pretty logical conclusion to make. It's not a perfect line though. If you were to connect these points, we would have like up and then straight over and then up and then up and up. And then these 2 points look like they're almost on top of each other. So They don't seem to be, we have like 2 values for 45. Yeah, we do. So that's not even a function. And then, yeah, so it's not a perfect line, but it's obviously a linear relationship, and that's what we're going at. Now, Desmos will find the line of best fit for you. So look at the top here. I mentioned this, that it says like X sub 1 and Y sub 1. So that's Desmos's naming convention. What we need to do is we need to decide on the family of functions that we want Desmos to do the regression for. So just because you have access to technology doesn't mean that you get a pass on knowing your math. So you need to look at this, say that looks linear, or possibly you might say that looks like an absolute value, or that looks like a quadratic, or that looks like an exponential, or whatever the family is that you're dealing with. So you look at it, you say, that looks linear, and then you need to know the form of a linear equation, which in this case we'll be using slope-intercept form. So here's how we do it. We're going to type y. Oh, not right there. Click down here. Okay. We're going to type y, but we don't want it to be like generic y, and we also don't know what the values are. We want y sub 1. So the way you do that is you just type y followed by a 1, and Desmos will automatically put it in the subscript for you. Now, we also are not going to use an equal sign. Okay, if you're doing a regression, you are going to use like a little tilde instead. Okay, and that's just what we would call like learning how to use the platform and learning how to use the program. Not every graphing calculator, graphing utility is going to do it the same way. That's why we have a separate video for how do you do this on Desmos. And we know that the form for the equation of a line is y equals mx plus b. So I'm going to type in m, and then I'm going to type in x, but remember I want x sub 1. So I will type the 1, and then I will do plus b, and there is the line of best fit. And you can tell that it goes through some of the points. Okay, it looks like it goes through some of the points, but not all of the points, and that you have roughly the same number of points above the line as you have below the line. And I know I say in the lesson video that when you're picking the points on the line to try to do like your own regression, you would try to pick lattice points, which are these like points right here where you wouldn't have to estimate. Okay, so scrolling down here, it tells us our parameters. So the rest of this has to do with different statistics kinds of things, but we're not in a stats class. So we're going to look at the parameters. All right, and what it's telling us is that for this green line that we have graphed over here, the slope is 2.6 and the y-intercept is 64.9968. Okay, you can round that to 65. And so when we go through the actual lesson presentation on this, you might be wondering, like, where did they get those decimals from? Like, wow, this is where they got the decimals from. So definitely take some time to practice. Just watching me do it is not enough to ensure that you can do it. So when we get to some of those practice problems where you are asked to use technology to do a line of best fit, you need to come in and actually do this yourself. Otherwise, you'll forget where to click and whatnot. So I hope this video helps clarify some of the things in the lesson, and the next time we have to do a regression, even if it's not linear, okay, so it might be quadratic, just as we go through the different families of functions, you will be able to do it.